Morning. So this is the assignment that you missed on Tuesday. I'm just going to run through the notes on this. After you're finished with this, you are going to do the cool down from March 16th. So when you're done, do cool down March 16th. After that, you will have the quiz March 17th, 19th. Okay, and that's over volume and volume of a right prism, adding and subtracting fractions. So that's work you've done in the past 2 weeks. So you're not being quizzed on this content, but content that you've already practiced. Okay, so the prism that we're looking at is right here. Some things we can measure about this prism is we can measure like the height, length, surface area of any face. So we can do like the rectangles or this base right here. Okay, so those are things that we can do. And then we can also do the volume. Oops. Volume. Volume. Okay. And what kind of units would we use? Well, this says in inches, but if I can do something in inches, I can also do centimeters. I don't think I'd want to do feet or millimeters or meters because then that would lead me into decimals. So always choose an appropriate measurement. If we can do inches for area, we can also do inches squared and centimeters squared. And likewise, if we can do inches and inches squared for volume, we can do inches cubed and centimeters cubed. Okay, so if you need to pause the video to copy these notes down, please do so. This is in the physical packet that you picked up on Monday, if you don't have this out yet. All right, so let's go on to problem 2. So we're looking at this, and the teacher wants you to calculate the surface area, okay? So the surface area is if we were painting this, what is the area of every single face on this prism? So you kind of have to imagine the back also. So all of these rectangles are 11 inches, and every rectangle is 2 inches across. But how many rectangles do I have? Well, I'm going to look. So I say a rectangle comes down from every side on this face. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 rectangles total in this prism. And then I have a base at the top and a base at the bottom. So nothing is open. It's a completely closed figure. All right, so Noah says it's going to be a lot of work. We have to find the area of 14 different faces. So the 12 rectangles plus one on the top and one on the bottom, that's 14. Elena says, well, I'm going to look at it a different way. It's not so bad. All rectangles are identical. Every single rectangle has a base of 12 and a height of 11. So she would just figure out one rectangle area, multiply it by 12, and that would give her the area of all the rectangular faces, and she would just add on the areas of the two bases. And then Andre says, wait, if I unfold this into a net, completely unfold it, I can do one large rectangle instead of 12 smaller ones, and then the area of the bases. So all you're going to write now, you pause your video, do you agree with any of them? And then explain your reasoning. And you can agree with more than one, or you can agree with only one. Okay, so actually every single method would work as long as we add on the two bases to Andre. Okay, so every single method would work. We can do each face individually. We can do multiply one of the rectangles by 12, or we can unfold it into one large rectangle. So you can agree with one, right? That's your answer. You don't have to change your answer. You answered something different. But we have to imagine what that large rectangle that Andre is talking about. So if I were to unfold this net, Andre is looking like this is how tall it is. I'm going to unfold it all the way. So this side is 11, and then we need 12 rectangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whoops. Each one of these lengths here is 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So it's 11 tall and 24 wide. So it would be 11 by 24. 11 inches by 24 inches. But remember, we have those two bases that look like that. I'm doing this for a reason. The bases are composed of 5 squares. Each of them are 2 by 2. So essentially we have 4, 4, 4, 4, 4. So each base is 20 inches squared. Okay, so what I'm going to do now, I'm going to open up a whiteboard really quick. So let me pause my video. Okay, and now you don't have to take notes on this, but we are going to compare Noah to Elena to Andre. Okay, so Noah says we have to take each rectangle and multiply and add them up one at a time plus the two bases. So if you remember, each rectangle was 11 by 2. So each rectangle is 22 inches squared. And the bases, we did 4 times 5. Each square was 4. 5 of the squares was 20 inches squared. So we do 22 plus 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 22. I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus the two bases, 20 plus 20. If you put this in a calculator, you gotta be really careful adding these all up together. We have 14 faces, so he was right. This does seem like a lot of work. You should come up with 304 inches squared for the outside surface area, okay? But if we look at Elena, Elena says we just need to take that 11 times 22 12 times. And we add in 4 times 5 2 times, okay? This is 40. 11 times 22 12 times is 264. Not 11 times 22, I'm sorry. It's 11 times 2. So 22 times 12 is 264. And we add those together, we get the exact same thing, 304 inches squared. So you compare those, Elena seems like a lot less work. Now Andre is going to take that original, so we've drawn out the net for Andre. Don't forget the bases. Now I'm only drawing the net because conceptually I need you guys to see this. So 11, 24. So he knows when I unfold the net, it's 11 across and 24 the height when we unfold all of those rectangles. So Andre says just do 11 times 24 and add to that 2 times 20. Each one of these is 20. So again, I have 264 plus 40, and that's 304 inches squared. Okay, so when we compare these, Andre, this is his work right here. Elena, this is her work right here. And Noah, this is his work right here. When we look at those three different ways of doing it, which one works all the time? So you're going to answer always, sometimes, never. Well, we got the right answer for all three of them. So sometimes, always, they work. But which one of these will always work? Well, Noah's is foolproof. If you take the area of each face and add it together, you can always come up with the total surface area. Even though it seems like a lot of work for this one, Noah's method we're going to see will work better for prisms with a smaller amount of sides. Elena's method works really well there, but if I want you to look at this one right here, you will notice that these lengths are all different. So we can't actually count on a prism having the rectangles having the same length. So Elena's will not always work, just sometimes. Andre's method relies on using a net. Any prism we can turn into a net. So Andre's method always works also. That doesn't mean Elena's method is wrong, but it only works in certain situations. So now I want you to pause the video, copy these notes down, and then answer question 4. Okay, so you should decide which method you prefer and why. So it could be Noah's because you can make less mistakes. It could be Andre's because it seems like less work. But either way you choose is fine. Okay, so we're going to talk about a pentagonal prism here. Okay, so we have to look at this pentagonal prism. Now we're going to actually look at both methods really quick and see which one you prefer, which is a little easier. Okay, so the first thing we need to do is we need to calculate the surface area. I would say for both methods, drawing a net is really important. Okay, so I'm going to focus on this pentagonal base first. Okay, so we have one up front and we have one in the back. I'm going to redraw it right here and we're going to label it. So we're going to come up with the surface area of the pentagonal prism, and there's 2 of those, so times 2. Oops, I don't want to draw that right there. Times 2. Okay, so this is kind of weird, but I've got 3 here, 5 here. This length right here is also 5. The bottom is 7, and the side over here is 2. So we need to come up with the surface area for that. So what I'm going to do is I'm going to divide it up and see what kind of shapes I have. So it looks like I have a rectangle here, and a triangle here, and a rectangle there. Okay, so this rectangle is 3 across, and it's 5. So 3 times 5 equals 15. Then I'm going to look at this rectangle. Now it's 2 up and down, but it's not 7 across. The total is 7, subtract 3. This length is 4. Okay, so just this small rectangle here. It's 4 times 2, which is 8. Now this triangle right here, I've got a base of 4 because it's right across from that one. The base down here of the rectangle is the same length of that little rectangle. And I need the height though. Okay, so 2 over here, 5 total. 5 minus 2 is 3. So my triangle is 3 times 4 divided by 2. So that's 12 divided by 2, which is 6. Now I need to add those together. 15 plus 8 plus 6 is 29. 29 times 2 is 58. So the two bases, the surface area total of the two bases is 58 centimeters squared. Okay? Now, I want to look at these rectangular sides. And the best way for me to visualize it is I'm actually going to draw it out. So I'm going to stretch out and unfold those rectangular faces and see how long they are. So I'm going to start with this side right here, which is 5. It's not labeled there. So 5. The top across here is going to be 3. And then this side, if I look to the back where it's labeled, this is also 5. So it's 5. This side right here is 2. And then I know that's not accurate, but the bottom is 7. Okay, so this is pentagonal, which means it's 5-sided. That means I should have 5 rectangles down here. Okay? Sometimes they'll be all the same length, sometimes they'll be different lengths. It's really important to label and visualize those rectangular faces stretched out, okay? But now, how long are these rectangles? Because I've got all the lengths over to the left, but how long is it? Well, I'm going to go back to my prism, and I can see that these are 8 centimeters. It's 8 centimeters. Okay, so we're going to add the area of all the faces. So let's try that. So if this is 8, this is 8, this is 8, this is 8, this is 8. So this guy would be, I'm going to use my blue for this. This is 5, 5 times 8. This one is 3 times 8. So I'm calculating the area for each one separately. 5 times 8. This is 2 times 8. This one is 7 times 8. Okay. So now I have all these separate areas. 5 times 8 is 40. I need to add them together now because we need the total area. Plus 24 plus 40 plus 16 there plus 56. Okay. So now we have to figure out what the total area after you add those together. Why don't you go ahead and try it? You get 176 centimeters squared. So now I have the area of all the faces and the bases. So I need the total area. So the total, actually I'm going to write it like this. The surface area of this prism equals the area of the bases in the area of the faces. So the rectangular faces. So the bases was 58 centimeters squared. And the faces is 176 centimeters squared. And that gives you 234 centimeters squared. Okay? Alright, so if you need to copy down, go ahead and pause the video. So I am going to do the perimeter method now, and I'm going to show you how that is going to work. Alright, this time, instead of doing each one individually, we're going to see what the perimeter of this is. So the perimeter, so the distance around this pentagonal prism. And we're going to see if we come up with the same thing. So you can see all the lengths are right here along the side of this rectangle. So this line right here represents the perimeter. So I'm going to do 5 plus 3 plus 5 plus 2 plus 7 equals the perimeter. Let's see, 13, 15, it's 22 centimeters. And then we can multiply that by the base here, or the height, which is 8 centimeters. When you multiply those together, you should get 176 centimeters squared. So the total area, the surface area, again, is the area of the bases plus the area of the rectangular faces, which you would come up with the exact same thing. Both methods work. Both methods are completely okay to do at any time. It is up to you to figure out what you're comfortable with and what you understand better. Okay, I do believe that is it for this lesson. It was a pretty short lesson. But I want to give you a few more examples before you do the exit slip. So I would like to look at these. So I have this prism right here, and all the measurements are given. So we have to figure out what we're going to do here. So what I'm going to do is I'm going to look at some faces that I can see. This face on the top. See this face on the side. Okay. This is rectangular. So now I have 2 green, 2 orange, and 2 blue. What are the measurements of my green? So it's 2 times, well, it is 10 high, because I can see that this whole prism is tall, 10 tall, and then 8 that way. So it's 2 times 8 times 10. And I'm going to add to that my orange. So there's 2 of these orange, one on the bottom, one on the top. The measurements on that are 5 times 8. I'm going to add to that my blue. Blue, not purple. And there are 2 of those also. And I can see these are 10, but what is this length? Well, this is the same as this. And if I look across, I can see this length is 5. So it's 2 times 5 times 10. So 8 times 10 is 80, so 160. Oops. A different color here. 5 times 8 is 40, times 2 is 80. 5 times 10 is 50, times 2 is 100. So take a second, figure that out. You should come up with 340 units squared, because it's area. So we square it. Okay, let's look at the triangular one. Okay, so I'm just going to highlight my bases really quick. Oops. And I have 2 triangles. So the area of the bases is 2 times the area of those triangles. So 8 times 6 divided by 2. So 8 times 6 is 42, divided by 2 is 21, times 2 is 42. Alright, now I need to look at these faces, right? So I have 3 rectangular faces. So I'm just going to kind of sketch out really quick what they should look like. So this first one is 8. This second one right here is 6. Oops, I'm in the wrong place. And then if I look at the third rectangle, I have to go to the back of the prism to find out what that length is, and that's 10. These will all be multiplied by 15. So I have 8 times 15, I have 6 times 15, and I have 10 times 15. I have to add those together. I'm going to get my calculator out and we can do that at the same time. So 8 times 15 is 120. 6 times 15 is 90. 10 times 15 is 150. Add those together, I get 360. Okay, so now I have 42 and 360. To add those together, surface area is the area of the bases plus the area of the faces, which is equal to 402 units squared. Okay, so your cool down is going to be a hexagonal prism. So I want you to be careful when you're doing that. You're going to have 6 rectangular faces. So you can stretch it out and redraw it. Just do whatever you can. But remember, always add the bases to the faces. Okay? All right.